Hello everybody, what's happening? So, coming to you live from the basement here. Today what we're going to do is I'm going to go over section 5, how to factor polynomials in the form of ax squared plus bx plus c. And in this first section of factoring, our a value is going to be 1. So you will not see a coefficient for the quadratic variable, the x squared variable. Now, to understand how to do this, you want to go back and you want to re-practice how to multiply your two binomials. So remember, when I'm going through something like this, I'm going to do FOIL method. I'm going to do first times first. There's our quadratic term. Then I'm going to take the outers and the inners. So plus 2x. And then insides plus 3x, which together give me positive 5x. And then last times last gives me positive 6. I'm going to bring everything down to the same line. So we can see that this back term, our constant term, was built by multiplying these two back numbers. And our linear term, or the x to the first power term, was built by combining outers and inners. If we do it again, same numbers, but I change the sign. First times first. My outers, negative 2x. My inners, positive 3x. Last times last, this time it's negative 6. Now you can see with the mixed signs here, I end up subtracting my two middle terms. So negative 2x, positive 3x, that combines to give me positive 1x, bring down my x squared, bring down my minus 6. Again, the back term came from these two multiplying each other. The middle term comes from the two middle terms being combined. And with the unlike signs, they end up subtracting. So with that quick review, if we start with the trinomial and we have to work backwards to find the two binomial factors, when we have no a value, or there's an invisible 1 here, we can very quickly, well, first we would always look to make sure there's not a common factor between our terms. So that's what we learned in the previous section. Always look for a common factor first. If there's no common factor and it's a trinomial, I'm going to try to break it into two binomial factors. So I'm going to take the x squared, which in every case came from x times x, and I'm going to just break those powers of x up evenly into each factor. Now, in this first example, I know that that back term has to come from the product of these two. So I'm looking for two numbers who multiply to give me negative 12. So I've got, now sometimes we'll make a list over here. You've got 1 and negative 12, or vice versa, negative 1 and positive 12, 2 and negative 6, or negative 2 and positive 6, 3 and negative 4, or negative 3 and positive 4. So there are my possible pairs that can populate these back positions. And then you can trial and error this. You might pick 2 and You might pick 2, positive 2, and negative 6. I think I just picked them right on accident the first time. We're always going to go back through now and FOIL to make sure that the combination we picked works out. So that FOIL method really comes in handy because we're going to constantly go back and double check to see if we're getting the line above. So now x times x is x squared. Here I end up with my outers, negative 6x. My inners are positive 2x. That does combine for negative 4x. So I nailed it on my first guess. And then positive 2 times negative 6, that gives me negative 12. And I know now the two binomial factors are x plus 2 times x minus 6. Since the multiplying problem, it wouldn't matter if you had these in other orders, x minus 6 and x plus 2. That wouldn't make a difference. For the second example that follows along with your notes, here's our trinomial. Again, we have a 1 in the a position, which is going to make our factoring a little bit easier for us. I'm going to split that x squared up into x times x. Factors of positive 8. So these are same signs on the back terms now. And they have to combine to give me positive 6. So the only way I can have same signs combining to be a positive 6 is if both numbers are positive. So here I can say positive 4 and positive 2. X times x is x squared. My outers are 2x, and 4x gives me 6x. And remember, in class, we did this a lot of times. When we do our outers and inners, we just kind of jotted them off to the side. 6x, and then positive 4 plus positive 2, times positive 2 gives you positive 8x. These are the two examples that are in your notes. In your notes, there are steps that go along with it. After this, there's a couple for you to try on your own and check with the note answer key. All right, good luck.